Hello everyone, this is Doug, and in this video I'm going to talk to you about some beginning mole conversions. Specifically, we're going to practice converting between grams and moles to grams. This is a very fundamental skill for chemistry. It's really important that you get this down because it will save you a lot of stress and anguish later on. This is a longer video because I'm going to do a lot of examples. Feel free to stop at any time when you feel like you get it, but the biggest thing is to practice this as much as possible. For my students, I've posted a whole bunch of material on the websites for you to practice, and I recommend you do a ton in the book. But let's take a look at what our main goal today is going to be. I have this unit conversion roadmap. By the time you finish a whole class like Gen Chem or something like that, you'll be doing all of these conversions. Well, you'll be converting them between the mass of one thing and maybe the number of atoms of a completely different thing through a chemical equation, or maybe you'll use molarity to figure out what the volume of a certain solution. These can get relatively complicated, but this is just a roadmap overall. What we're going to talk about today is just the conversions between the mass of something and the moles of that thing. So how many moles of them, how many moles of atoms or molecules there are with a certain mass of things. That's all we're going to focus on. And so you'll see that what we're going to need to know is we're going to need to use the molar mass. And that's going to be the thing that we use the most today. So let's take a look at some examples here. So I like to organize my information like this. So if I'm being asked a question like how many grams are in 0.054 moles of copper, first I just sort of organize my information with the known amount, the unknown amount, and the conversion factors that I think I'm going to need. And the trick with all of these problems is that I'm going to need to use some sort of molar mass. And I'll show you what I mean in a second. So in this question, my known amount, right, apparently my known amount is this, right? Here's how many moles of copper I have. I have 0.0540 moles of copper. And what it's asking about here is it's asking how many grams, or what's the mass, what's the weight, how many grams. So I know I'm looking for grams. And that's going to be my ending unit here for my unit conversion that I'm about to do. And as far as the conversion factors that I may need, for all of these mole to gram, gram to mole problems, you're always going to need a molar mass. So I'll just write down, I know I'm going to need a molar mass of some sort. Since in this case it's a pure element, the only molar mass I'm going to need is that of the actual element itself. So molar mass. And if I want to know the molar mass of copper, all I need to do is just take a look at the periodic table. And what you see down here, right, is the atomic mass, the atomic weight of copper, right? And remember that that is in grams per mole, which is the two units that we're talking about here. We're trying to learn how to convert between grams to moles and moles to grams, which is exactly what the problem is asking. So I can write over here, I can write this conversion factor in a variety of ways. I can say that there are 63.546 grams per mole. I can just write it like that. Or I can write them one over another. So 63.546 grams over 1 mole. Or I could write it a third way, 1 mole over 63.546 grams. So all three of these, right, all three of these, 1, 2, 3, all three of these are saying the exact same thing, right? That if you have 1 mole of these copper atoms, it weighs 63.546 grams. And what I'm going to need to do is figure out how I want to arrange that so that I can actually solve this problem. Now in this particular case, I don't think I need any other conversion factors. I really just have this one. I have the molar mass one. I don't need like how many milliliters or in a liter or anything like that because it's not what this problem is talking about. But as you go through these problems, if you find that you do need a conversion and you didn't write it down when you're collecting your information, you'll see that it becomes pretty apparent. And I'll try to show you what I mean in a sec. So now that I have all my information, I just need to set it up, right? So I'm always going to start with my known amount. So 0.0540 moles. And then I need a conversion factor to put in here. And remember that with conversion factors, right, dimensional analysis, unit analysis, conversion factor, what I need to do is I need to get my units to cancel. So I need to get these moles to cancel out, which means that down here I need to have my mole unit, so that I can cancel out my moles in the end here. And to do that, it looks like, what I need to do is I need to decide, am I going to do this version, version A, or this version, version B? And it looks like in A, I have my mole on the bottom, but in B, I have my mole on top. So A is the version of this that I want to put in because it has the moles on the bottom. So I'm just going to take that and put that in as 63.540 grams for every 1 mole. And by doing that, right, by using this version and not version B, I'm able to get my moles to cancel out, which leaves me only in grams here. Right now my unit is in grams, which is exactly the unit that I was looking for, right? I was trying to convert into grams. So then I'm done. That's really all the work that I need to do. So I've set this up correctly. And what you need to do then at this point is all you do is you pull out your calculator and literally type 0.0540 times 63.540. Right? Remember that you multiply everything in the numerator and you divide by all the things in the denominator. And so when I plug that in my calculator, I get 3.43116. And then we just want to remember to express our answer with the correct number of significant figures. And again, if you don't remember what significant figures are, I recommend you go watch one of my older videos. But this has 1, 2, 3 sig figs. This has 1, 2, 3, 4, 5 sig figs. So my answer can only have 3. So I only get to use those numbers. So my final reported answer should be 3.43 grams. That's with the correct number of significant figures. And that is about as simple of a unit conversion, a mole to gram, gram to mole conversion that you can do. This is just the very beginning one. I just needed one conversion factor. That's it. And again, the trick here is to just use the periodic table to get those conversion factors and then set them up so that you get units to cancel. So let me do another example here, or another relative. So this one's asking how many moles of atoms are there in 583.22 milligrams of gold. So my known amount in this case is 584.22 milligrams. The unknown amount, it's asking about moles. I don't know how many moles that is. That's what I need to figure out. And then for my conversion factors, right, again, we know we're always going to need a molar mass for this. So in this case, I'm going to use the atomic weight of gold since the question is asking about gold. So I'm going to write that as a kind of as a conversion factor here. So 196.97 grams per mole. And I'm just going to write the one version. I'm not going to write 3 versions like I did on the previous slide. I'm just going to write this version, and if I need to flip it upside down, I will flip it upside down. So I've got the molar mass, relating grams to moles and moles to grams, but my starting amount was milligrams, not grams. So that means I'm going to need another conversion factor, right? I'm also going to need to relate milligrams to grams. And since I know that there's 1,000 milligrams for every gram, I can just express that conversion factor like that. So I could have said 10 to the 3 milligrams per gram, or I could have said that 1 milligram is 10 to the negative 3 grams. Any way you want to say it, those are all the same. Those are all the same. I think I've got all my information, so I'm going to go ahead and try to start putting this together here. Again, you start with your starting amount, so I've got 584.22 milligrams. I need to put a conversion factor in. Since I have milligrams right here, I'm going to use this conversion factor because it has milligrams in it. And you'll notice that the way I wrote this, 1,000 milligrams per gram, that milligrams is on top. So that means I don't want to put it in like this. I need to flip this thing upside down. I need to flip it upside down. So I need to turn this so that I have 1,000 milligrams on the bottom now and just 1 gram on top. And that's totally a fine move to do. You can flip these upside down or keep them right side up, whatever you want. The goal is to make the units cancel. That's what we're looking for, right? So now that my milligrams on top and milligrams on the bottom cancel out, I know that I can go on to the next stage. Now I'm in grams. So now my unit is grams, and if I need to know am I done or not, I just need to remind myself that for my unknown amount, right, I'm not looking for grams, I'm looking for moles. And so I know I'm not done, because right now my answer would just be in grams. So I need to add another conversion factor here, where I need to cancel out my grams and hopefully get moles. So that means now I'm going to use this one since it has grams in it. But again, this one's not flipped the way I want it. It has grams on top, and I want grams on the bottom. So I'm going to take this one, and I'm going to flip it upside down also, so that I get 197.97 grams on the bottom and 1 mole on top. And again, if I look at the units, it looks like my grams, gram on top and gram on the bottom cancel out, and that leaves me now with moles, which is the unit that I was looking for, so now I know that I'm done. And then I can just simply solve with what I've got. So again, you multiply all the things in the numerators and divide by all the things in the denominator. So 584, so 584.22, technically times 1, even though it's mathematically not that important. Then divide by 1,000 and divide again by 197.97. And if I punch that in my calculator, I get 0.02, actually one more zero. I get 0.0002950 and some more. I know I'm not going to need all those sig figs though. So in this case, right, if I want to make sure I have the right sig figs, I've got 1, 2, 3, 4, 5 on that, 1, 2, 3, 4, 5 on that, so I need 5 for this one, and I got 1, 2, 3, 4, 5. So my final answer would be 0.002950 moles. Got a little squish there. For my final answer, apparently that's how many moles of atoms are in that much gold. If you wanted to convert this into scientific notation, right, then you just talk about moving the 0 over 3 spots. So you could say 2.9510 times 10 to the negative third moles. That would also be correct. Either of those would be a perfectly fine way to answer that. So here's an example where I actually needed two conversion factors, one for milligrams to grams and one for the actual moles to grams conversion. Now let me go to another, I'm going to do another one, but now make it slightly more complicated because I'm actually going to have a compound in there. So not just a pure element, I'm going to have a compound with multiple different types of elements, multiple atoms, which makes as one little layer of complexity. It's not huge, but it's a little more complicated. So in this one, it's asking what is the weight of 1.20 times 10 to the 4 moles of sulfur trioxide, which is SO3. Now you'll note, right, it's not an element, I've got multiple elements, I've got this compound here. Process is going to be largely the same, but not identical. So my known amount apparently is 1.20 times 10 to the 4 moles of sulfur trioxide. I am looking for the weights, right? If it says weight, we know that's grams, 'cause that's how we weigh things in science. So I've got grams. And then for my conversion factors, right, I know that I need that molar mass again. I need to find that molar mass. I need the molar mass of sulfur trioxide. Now, if you look at the periodic table, right, I've got these two elements, they have different atomic masses. All you need to do if you want to figure out the molar mass of a compound is you simply just add up all of those molar masses. So since sulfur trioxide has 1 sulfur, so here's my 1 sulfur, and 3 oxygens, I just need to find the molar mass of 1 sulfur, which is 32.065 grams per mole. And then the mass of 3, so I'm going to put 3 times 15.999 grams per mole of the oxygen. So since there's 3 oxygens, I'm going to multiply that number by 3. And if you do that and then add them all up, you should get that the molar mass of the whole compound is 80.062 grams per mole. Or another way to express that to make it look a little bit more like a unit conversion, or excuse me, a conversion factor, is to just go ahead and put it in that form. And again, I'll flip it upside down or right side up if I want it later. So the key thing here is to pay attention to the fact that I only use the atomic mass of sulfur once because there's only 1 in that compound, yet I use the molar mass of oxygen 3 times because there were 3 oxygens in that compound. So if I want to know the total molar mass of that, or the molecular mass of that, then I have to multiply the oxygen by 3 and just add everything up. And I don't see any like milli or like kilo or anything like that in this particular problem, so I think that I only need the molar mass. So I'm just going to go ahead and start this problem, and I'll see if I hit any roadblocks. So I've got 1.20 times 10 to the 4th moles, and I need to put in my conversion factor here. It looks like it's set up the way I want it. Grams on top, moles on the bottom, right? So I can get my moles to cancel if the moles are on the bottom here. So I'm just going to leave this right as it is. So 80.062 grams for every 1 mole. Again, it looks like my moles cancel out. It leaves me in grams, which is actually what I want, right? I do want grams. That's the unit I'm in now. So now I know that I'm done. And then I just need to pop that into my calculator, right? So 1.20 times 10 to the 4th and then times 80.062. And if you punch that into the calculator, you're going to get 9,60744. And so if I go back again, right, don't forget your sig figs. It looks like I've got 3 sig figs here, and I've got 1, 2, 3, 4, 5 here, so I can only have 3 in my answer. So this would become 961,000, but these are ambiguous. You don't really know if those zeros are significant or not, so it's probably best to go ahead and put this in scientific notation and say 9.61 times 10 to the 1, 2, 3, 4, 5 to the 5 grams as your answer. So it's a pretty large amount of grams, pretty, you know, almost a million, so 961,000. And that's how we would treat a compound. If you feel like you're good to go, you can go ahead and ignore the next slide. I'm just going to do another example of this, another one that's just slightly more complicated, but I think hopefully you're getting the gist of how to approach these problems. So let me do one more. So in this one, how many moles of sodium sulfate are in 606.20 kilograms? So my known amount, 606.20 kilograms, so that's what it says. Unknown amount is asking for moles. How many moles? My conversion factors, right, like always, I'm going to need some sort of molar mass. Now, to figure out my molar mass in this case, they didn't give me a formula. I don't have a formula here. I don't see a formula. So what I have to do is I have to do a little bit of work on my own. I have to do the work of remembering how to convert names into formulas, right? Because if I see sodium sulfate, I know that this is my compound, right? Here I've got sodium sulfate. And so I need to remember that sodium is a +2 and sulfate is SO4 minus 2. Sorry, sodium is +1, sulfate is SO4 minus 2. And therefore the formula for sodium sulfate is Na2SO4. And so now when I go over here to figure out my molar mass, those are the elements and how many of each element I need to add up. So apparently I need 2 sodiums. So I'm going to go 2 times 22.990 according to the periodic table. I need just 1 sulfur. So sulfur was 32.065 according to the periodic table. Right, and I have these all over here, right? 22.099, 32.006. Oh, I put 6.5. Depending on the periodic table you use, they might be slightly different because of rounding. That's totally fine. I'll put 6.6 here to be consistent. And then lastly, it looks like there are 4 oxygens in sulfate, so 4 times 15.999 grams per mole. And if you add all of that up, you get 142.041 grams for every 1 mole of sodium sulfate. So there's my molar mass. I've figured out my molar mass. So I got a molar mass to convert between grams to moles, but notice that I start off in kilograms, so I need to figure out a way to get from kilograms to grams. And kilograms, you can either look it up or you can memorize it. Kilograms, right, there's just 1,000 grams per every 1 kilogram. So that's going to be a conversion factor that I think I'm going to need to use. I don't think I need milli or here or anything like that. Notice I'm not using Avogadro's number because nothing's asking about the actual number of particles, like the number of sodium sulfates or the number of atoms or anything like that. So I don't need Avogadro's number. And then last, we just need to put it all together, right? So start with your starting amount. So I've got 606.20 kilograms. That means I need my kilogram unit to be in here. I'm just going to leave this conversion factor as it is. So kilograms, 1,000 grams on top. 1,000 grams on top, so I just pop that one in here. That's going to give me, since my kilograms cancel out with one another, now I'm in grams. I'm not quite where I need to be yet because, I'm looking for moles. So that means this one needs to pop in next, but my grams here is on top, and I want it on the bottom, so it cancels, so I need to flip it. So I'm going to flip this upside down so that I get 142.041 grams and 1 mole on top. So now, like I was just saying, my grams cancel out. Now that leaves me with moles, which is exactly what I was looking for. I'm looking for moles. And then you just need to multiply and divide. So 606.20 times 1,000 times 1 equals divided by 1 divided by 142.041. And what I got here was 4267.7818, and it just kind of keeps going. I know I'm not going to need all those. And if I look at my significant figures, I'm starting off with 1, 2, 3, 4, 5. My other measured amount was 1, 2, 3, 4, 5, 6. So it looks like I only need 5. So 1, 2, 3, 4, 5. I'm going to stop here. So I report my answer as 4,267.8. Right, and I rounded that up because 8 is higher than 5, so you round up moles. So that would be my answer. Apparently there are 4,267.8 moles in over 600 kilograms of sodium sulfate. So that's how we approach these problems. Here's 4 examples. Again, this is sort of the beginning mole conversions. Things get a little more complicated when you start doing stoichiometry with reactions, but at the beginning, when you're just learning how to convert between grams and moles to grams, this is how you do it. If you have any questions or comments, please leave them down below. I hope that this gets you on your way to solving these mole problems. Remember that to practice this and practice this and practice this. Good luck.